Hello, everyone. We'd like to wish everyone a good morning, a good afternoon, or a good evening, depending on where you are in the world. My name is Samantha from Safeopedia, and here at Safeopedia, it is our mission to support you, our EHS professionals, operational folks, and any safety-minded individuals with free safety information, tools, and education. I want to give you all a huge thank you for all of the great work you do on keeping our workplaces safe and as well as being here today. That's the first step in keeping all of us safe. Just a reminder, this webinar is being recorded and we will send out a link to the recording to everyone in a few days. We will also have a Q&A at the end of this webinar, so make sure you get your questions and your comments into the Zoom Q&A and we will get to them at the end of the presentation. Today, we are proud to present ANSI Made Simple Practical Steps to Compliance for Emergency Safety Showers and Eyewash Stations. This Safeopedia webinar has been made possible today by Just Right. Today, our experts, George Venus and Al Condi, are going to help you identify the common hazards and violations, how to evaluate your equipment, and set you up with preventative measures to make sure that you're successful in the workplace. I'm very excited to have you all sit back, relax, and enjoy this presentation. With that, let's jump into it.
Perfect.
Thanks.
George,
Thanks.
how about you start?
Thank you. Yes. So like Samantha said, my name is George Venus. I work for Hughes Safety Showers. That is the safety shower brand for Just Right company. I'm located here at the factory from Hughes in Sarnia, Ontario. I am responsible for sales for Canada. I'm sales manager for Canada, but I also work as the technical support team for Hughes Safety Shower North America. Al?
Yes, I'm Al Condi. I am the regional sales manager for the East Coast, pretty much everything east of the Mississippi, about 24 states. I live in Charlotte, North Carolina, and I've been with the company about 6 years. My specialty is engineered solutions. So that's the part that I prefer to do. So, and I'm, again, part of Hughes, and which is, and our parent company is Just Right Safety Group.
Excellent. So today we're going to be talking about emergency safety showers. The ANSI standard that most companies and legal entities follow is the ANSI Z358.1, currently on the 2014 edition. What we're going to cover today is some examples of what to look for and how to identify when it's not right, when it's not working the way it should be. And Al and I will be discussing that today. So let's get this started. All right. So we're not going to go through the whole standard. It's long and it has many options, but we're going to talk about the key aspects when we're considering evaluating our safety showers on our sites. That's going to be temperature, location, flow, and operation. So the first part, which is one of the most important parts of the ANSI standard, is keeping the correct temperature. Right now, the ANSI standard states that the water needs to be on a tepid range, which is between 60 degrees Fahrenheit or 16 Celsius on the cold side and 100 degrees Fahrenheit or 38 degrees Celsius on the hot side. Al, why was this range set? What's the problem between lower than 60 or higher than 100?
Well, this is actually when I do surveys, when I go out to see clients, this is probably the #1 issue that I found is that the water is not tepid. And what happens if the water is too low, you could get into hyperthermia, causes a whole other set of problems. And if it's over 100 degrees, you're literally burning your eyeballs. So so the standard keeps it between 60 to 100. The optimal is about 84, 85 degrees, and that's what most of the units should be set up right around that area. Like it says here, the prolonged exposure causes many issues from the hyperthermia to burning. This is why the standard was set between 60 to 100 degrees.
Correct. And this temperature needs to be maintained during the full 15 minutes. So everything we're going to talk about today needs to be maintained for 15 minutes, which is the time period needed by the ANSI. Why do we need to remain 15 minutes taking a shower, Al?
Well, 15 minutes is what has been studied over time. 15 and sometimes even longer is needed, but 15 has been the minimum that we found. And basically the standard says you put a copious amount of water on you, basically to to take everything off your body, your skin, your face, your clothing. You want to put an abundance of water, and the 15 minutes is what we found in the standard to be the optimal amount or more.
Correct. So let's go to the next section, which is location. And this is also sometimes creates confusion with people about the location. So the first thing is 10 seconds. When that's measured about the distance that a normal person walks, which is about 55 feet. So the actual requirement is that it needs to be about 55 feet from the hazard maximum. But it's also a problem if you're too close. And then it has to be on the same level, no obstruction, highly visible sign. Al, what do you find when you're looking at locations of showers and your customers about this 10-second, 55 feet requirement being sometimes too close or too far away?
Yeah, in the recent surveys, I found that they do have a safety shower, but the safety shower is literally right against a hazard, causing another set of hazards because you have this slurry and these chemicals, these electrolytes that could actually fall on top of the person that's trying to take whatever has hit their body, their eyes, etc. So in reality, you have to look at where the hazard is, and when it says 10 seconds, you got to bring it out of the area of the hazard as well. So you got to put it within those 55 steps, 55 feet or 10 seconds to be able to cover it. And also, there's always hazards. I always find hazards in the area. Steps, like the standard allows for one step up or one step down, but I'll find in like a tank farm, it'll be 3 steps up. Well, now you need a whole other safety shower on the top of those 3 steps because now you surpass the standard. It's only 1 step up or down. And also obstructions, I find hoses, garbage, I found retaining walls, all in the area, all are considered obstructions and can affect the person getting to the safety shower. And another one is doorways. I find a lot of places will have a door with a lock or just a handle. It is not allowed. You're allowed a push bar toward the hazard. That's allowed. But handles or a door that's locking is considered an obstruction and is not allowed. And of course, the visible sign. The signs are not only there for the person or the people that work there, but also for people who might be visiting. So these signs have to be visible. If there's something that happens, a visitor, not only the person that works there, but the visitor has to be able to know where to go. This is why the signs need to be in a position where it could be seen easily, no obstructions, and also I find a lot of faded signs and things like that. All those should be taken care of, and of course, well lit. Have an area light for the shower, or have some lights in the area so that you actually be able to find where the shower is at.
So if I hear you correctly, the basic idea is if I run into an emergency where I have something in my face, in my eyes, I'm not thinking straight. I need to be sure the shower is close by. There's no obstruction, which might trip me over on my way there, highly visible. I have good signs so I know where I'm going, so I can reach the shower within 10 seconds of any accident happening. That sounds like a good thing.
Absolutely correct. And in most hazards, you're supposed to have at least 2 people there. So hopefully you have somebody that will guide you there. But if there is a hazard and nobody's around, people close their eyes and start feeling the way through to where the shower is. So this is why you have to keep it completely clear, visible, know where things are. And that's also part of training.
Perfect. All right. So the third, it's flow. And this one is very tricky. It requires a lot of things and sometimes not even related to the showers. So you need the shower to run at 20 gallons per minute, 75.7 liters per minute. That's a lot of water. I always use the example, those 5-gallon jugs of water, it's 4 of those every minute coming out of that shower. So that's a lot of water. And then all for 15 minutes, right? So that's 300 gallons of water that are going to come out of that shower during the time. So that's a lot of water that sometimes customers don't realize there's going to be so much water coming out. And for the eye face wash, we're talking 3 gallons per minute. So there's enough water to go around your face and your eyes and to be covered completely. So what are the biggest challenges meeting these goals of gallons per minute, Al, when you go visit your customers?
They don't have the right size pipe is one of the big ones, or very old pipes that have degraded over time and have just restricted the gallons. So it's not about pressure, it's about how much water can go through those pipes. ANSI is so specific that you need a minimum of 1¼ inch pipe to be able to achieve this number. So over time, even if you have the right size, it could get corroded and and restrict that flow. So that's one of the, again, probably the number 2 or 3 things that I find when I go there. They don't have enough water flow.
Correct. And sometimes it's the piping. So not even the shower. You may install a brand new shower there, but you still might not be meeting the requirements because it's the piping feeding the shower, not the shower itself.
Correct. And this is where a professional is very important to come in to help you in your situations, because there are options available now where if you don't have enough water flow, there are options available to create. We have certain products in the market now that could actually help you with that. In a lot of cases, repiping can cause hundreds, if not millions of dollars to repipe. So there are options in the market that you do not need plumbing. So that's always get with a professional to help you walk you through that.
We may see some examples here later on about that. And then putting all this together, the correct temperature on the right place and the right flow, everything needs to be from off to on within 1 second on this one. Easy to operate. When you open the shower, needs to stay open until intentionally closed. And you don't need to use your hands to keep it activated. So why is this important when using a safety shower?
Well, the requirement is 1 second because you want to have tepid water almost immediately. And this is where we have the temperature issue versus the operation issue, where you have to have tepid water within 1 second. So the water has to start flowing at the right temperature, at the right flow amount, because too much is bad and too little is bad also. So we have to have the optimal amount, coming through so that the person can thoroughly be washed off without causing additional harm.
Correct. And it's a challenge sometimes getting 20 gallons per minute to the right temperature immediately if you're either on a warm area or even more challenging where you're in a cold area, like up here in Canada, that sometimes requires extra steps to get that water warm. All right. So
and then talking about operations, sometimes it could be as simple as putting a scald valve, or it'd be as simple as getting heat trace onto the unit. So there are options out there to help you get to this, but the 1 second is crucial to not harm the person who's been already injured.
Good to know. Good to know. The other part that the ANSI talks about is the spray pattern. So it says that it needs to be about 20 inches wide, 60 inches from where the person is going to be standing. That's not the pattern I get from the shower at my house in my bathroom. Why is that pattern that way? What's that requirement about?
That has to do with making sure that it falls around your shoulders. So it's an average person at average height, and that's the 20 inches. Obviously, there are people that are taller and there are smaller, but that's for an average sized person to be able to hit the standard. 20 inches is usually what you need to go around your shoulders.
And then I understand that this spray pattern requires there's got to be full coverage from the center to the edges. It's not like you're only getting a cone of water on the outside. It needs to be a coverage all around, right?
Right. That's actually a great point, George. So when I do the assessments, we go out to clients, most people use shower roses. And what I've noticed over time is the middle, there's no water coming out of the middle. It's always coming around the sides. So what happens in the middle, there's almost nothing or maybe some dripples of water. So that part is a part that corrodes very easily. The shower roses. I mean, I've seen shower roses with a bird's nest on them and wasp nest. So there's a whole other hazard there. Try to turn this on, you activate the hornets or the wasp, and it's going to be another problem. So this is why I recommend a different type of shower nozzle that you don't have all those issues as the one you see in the picture.
Makes sense. I definitely don't want to shower with hornets.
Correct.
Then for the Eyewash, again, you want to be at least 7 inches, 6.9 inches from any obstruction, and you need to be between 33 and 53 inches. That makes sense. Why is that distance required?
Because you have to be able to get into the position to be able to cover your eyes and the shower all at the same exact time. So the average, 33 to 53, again, for an average person, some people, are going to be taller, some people are going to be shorter. But as long as you get within those 33 to 53 inches, the average person should be able to use it. And the obstructions is literally, I've been to some places where there's a bar next to the Eyewash, or like, let's say, something, a retaining something, a wall, or whatever. How can the person get in there? They can't. So that the obstruction is so that person can actually get and put their face into the safety shower.
Especially if you don't have visibility, you have something in your eyes, so you need
Correct.
to be
You
sure
can't
it's clear.
see. Yeah, you end up banging into the wall or hitting your head and
Yeah.
causing more
And then
hazards.
the ANSI also specifies the height, so you don't have a shower that is too tall or too low for the average person, like you said.
Right.
And it's the lever to turn it on also needs to be no more than 69 inches. Again, probably because of what you said, the average height, so people can use it.
Height. Exactly. And in a lot of cases, we don't have enough room, so we have to sometimes say no. But the 82 inches is really the minimum for an average person to be able to get inside and have those 20 inches go around to around their shoulders. And another issue when I go around is many times the shower is not over the Eyewash. And that's also another hazard there. It's supposed to be right over each other so that you could simultaneously use the Eyewash and have a shower coming on you. So it cannot be on the side. It has to be all in line all together.
Excellent. So that's a lot of theory. We talked about a lot of what the key aspects. Again, the ANSI standard covers a lot more about different types of shower, from shower, Eyewash, eye face wash, combination units, right, supplementary units, alarms, and all this type of things, and more details. And anybody with experience, we can help you just get the details exactly of what the shower is. But let's go to some practical ideas, how to identify what does this look like when you go out in the field. Let's start with this video. This shower, it actually working properly. You can see what is good about this, the way the shower is working.
Well, you notice it turned on immediately, so it's within the 1 second, and the shower also activated within the second. It also has a really nice pattern over the 20 inches, and then you see the eyes are right up. It's supposed to be 8 inches, and your eyeball is supposed to fall within the flow rate of the Eyewash. Now, should I tell them about what the problem is, George?
Exactly. So the shower looks good, but I think there's a problem here. What's the problem here? I don't know if anybody noticed it looking at the shower working so great, but I think there's a problem here. What's the problem in this picture?
Well, obviously, as you can see, there is a bar right next to the left side of the Eyewash. So there's no way that a person can get in there and get a proper shower and Eyewash. So I would pass it myself as the shower and Eyewash working, but it's an immediate fail because of an obstruction. There's even a bar behind it that's too close that could probably hurt the person in the back, on their backside when they try to get in there. So it causes a whole other set of hazards that it shouldn't be there. But by simply moving it, just slightly putting it at an angle, you should be able to meet the standard.
Yeah, so if helping with an expert, if you look at this location, so having this shower just turn 45 degrees to an angle, that should give you enough room, and that shower should pass on that one. And that's the kind of things that sometimes they're overlooked on it. Let's take a look at another example here, Al. So this shower, taken from one of our customer visits. What can you tell me? What's wrong with this picture? I see a shower and an Eyewash.
Yeah. Well, if I'm looking at this right now, I see that the shower pattern is just too haphazard. It's just not hitting the 20 inches. I don't think you're getting enough water flow. And what tells me there's not enough water flow is by looking at the Eyewash. The Eyewash water flow is too low, so the person really wouldn't be able to get both of their eyes in there to be able to wash their face and their eyes off. And in addition to that, there is these 55-gallon drums in the back that I think they're a little too close. And I've seen some pallets, I think, in the back there. So a lot of issues on this one. Can we see another angle?
This water, we do, but this water flow that you see here, what could be causing that type of flow there? Several
issues could be. It could be just not, the pipe is not big enough to cause the water flow. But looking at this, I think the shower rose is probably clogged up. But
It
then
might
the
be just
problem that I
a faulty
have,
shower rose.
yeah. So, but the other problem is, look at the Eyewash. It's not enough water flow for the Eyewash either. So there might be several issues happening on this one.
Correct. So let's see. I think we have another angle for this
Ah.
picture here.
So
So
what's the problem
it is a
here?
shower rose fitting this.
So big issue is the shower is not over the Eyewash. So that's a full fail. Okay. But look at that, as you can see, the water is around it is coming out pretty heavy, but looks like there's almost nothing in the middle of it. And it doesn't hit the 20 inches either. You could clearly see that. So there's lots of issues happening here. I would fail this completely. For water flow, the shower is not over the Eyewash, and I think there's other obstructions. I think the one in the back.
Goes by on the other side.
Yeah.
I can see the water feeding here over the top, but looks like there's not enough flow on that one. So that might be that the side doesn't have enough flow coming in for the shower.
So you notice the shower, it looks like it's a 1 1/4 inch shower, but look at that pipe. It looks like maybe a 1 inch, I'm thinking, maybe even a 3/4 inch a pipe. What do you think? And so that right there is
maybe a reducer there.
Yeah.
And the other thing sometimes we see on these units is, and the ANSI standard actually mentions it, is a valve to isolate the shower for maintenance. I don't see one here, but sometimes we see valves feeding the shower. And there are some issues sometimes because you can put a valve there, that's no problem. But the ANSI calls for a specific requirement on any valve feeding a shower, right?
Yes, it does. This is part of the 2014 standard. The change that was one of the changes they did. So the valve actually has to be tamper-proof, and it has to have
multiple, right?
Multiple, and it has to be able to have a lockout tagout capability. So so if the shower is not properly tagged, and somebody goes to use it, there's another issue and fines that could occur. So you need to have.
I think that's very common.
Valve.
I mean,
very
customer
common.
visits I've done, that's very common in some sites, correct?
Easily 60-70% of the units don't have the proper ball valves. Easily, maybe more.
Yeah. All right. Let's see. I think we have something else. Huh.
So this one, as you can see, the problem is that the flow could have probably blown your eyeballs out. So it's too much water flow. And this is a common problem that I see when I do there. It's either too much or too little. A standard unit just doesn't have the ability to be able to moderate that pattern. You would have to change out the unit. Sometimes it's sometimes some people take off the aerators and there's too much water flow going through there, or they're clogged up and not getting enough. On this particular model, I noticed that it has a valve. I saw the guy working on it that could actually move that pattern to be able to do that. So that's actually probably one of the best things I've seen, is that you have the ability to move that pattern to the right one. As time goes by, water can go up, can go down. That little valve alone will be able to save, not replacing the whole unit out.
Correct. So, but definitely the way that started, it's something I don't want to put my face on, but seeing it now after it didn't adjust it, that should be good on that unit.
Correct. I also like that it has the cover that pulls downward away from your face. I've noticed that most clamshells or closed bowls, the bowl opens upward and hits you in the face, especially when your eyes are closed, you don't know what's going on, it hits you. This one, I like that it pulls downward and it has the valve.
Yeah, it's more natural to just lean on it and just take it down, and that activates the unit.
Correct.
Okay. I think we have another video here on this one. What do you see here, Al? What are the issues on this video?
Well, first of all, you see the obstruction, the bar is right next to it. Again, hopefully just moving it about 45 degrees should be able to give you the right pattern. But there's not enough water coming through. You don't get the 20-inch pattern. I could see that clearly there. There's a lot of water going around the side, but I don't see what's happening in the middle. I don't like that pattern. Plus, I don't see the Eyewash on, so I'm not seeing the full thing. What's going on? I like how it's creative.
You have to be, looks like you have to be on those rails to get the shower.
Literally. Yeah. So you're hanging over the rail. So you won't be able to get the full pattern, and plus you won't be able to use the Eyewash at the same time, which is part of the standard. So I would fail that due due to a bad pattern. And something as simple as changing the shower rose might be the fix to this, something that simple. I can't see the side of the pipe going into it, so I don't know if it's a water flow issue.
Yeah. But there's something good about this one that's not always there. I see this unit is installed on at a height level. It's not a floor level. What can you tell me about that?
Well, part of the standard is that you have to be between 10 seconds or 55 steps of the hazard, and you can only have one step up or down. So this is a thing that I find many times is when you're at height, they don't have a safety shower put in there. I see that a lot in tank farms where there's at least 2 steps up, and that needs a whole safety shower. What I like about it is they actually have a shower in a up at height area, but the problem is just they did not put it in the right position.
Thing, and you were mentioning this about the shower rose, but these uncovered eyewash, which are pretty common, we all have them as an offering, but it causes an issue sometimes offering these open bowl eyewashes. What have you seen in your customers when they implement these open bowl type eyewashes?
Well, I've seen so much stuff. First of all, I don't even see if this one has caps on it or not. I'm not seeing them. So you're supposed to have caps so that you don't have junk going into the eyewash. And it's supposed to, once you hit the paddle, it's supposed to pop the caps off. But the big thing is, I've been to, I'll give you an example. I went to a meat packing plant not too long ago, and there's literally pieces of meat inside of it. That's disgusting. And people were actually using it as another one that I saw, they were using it as a water fountain. I said, no. And one of the worst ones I saw was at a poultry farm, a kill site, unfortunately, and literally bird poop and stuff inside of it. It's just nasty. This is why I'm a proponent of covered eye washes. But again, if you don't have that, at least have the caps that are proper and have somebody cleaning these things out on a regular basis. So it's disgusting.
You mentioned something interesting a moment ago, that a customer was using it as a water fountain. The standard requires that every emergency safety shower and eyewash is fed with potable water. So what's the difference there for an emergency safety shower about the water that needs to be used on the shower?
That's another very good question. See, people get confused between potable water and basically city chlorinated water. So potable water can actually be water that you could drink, you buy it at the store. It can even be potable well water. But what you actually need, and this one is city water that's been chlorinated. And the reason why you need the chlorination is because there's a lot of bacteria in water. If you leave water sitting for more than a week, you start building up bacteria. This is why these units have to be tested weekly. It's not because for water flow, which is one of the reasons. It's really to purge the bacteria from the pipes. You probably notice in cruise ships, they get a lot of Legionnaires' disease. Why? It's because stagnant water is sitting in the pipes. You got to purge these pipes weekly so you don't have this, and you need chlorinated water. If you do well water, it actually destroys these units. And if it's too clean, like DI water cannot be used, it actually will leach the pipes and create another issue. So you want city potable water that's chlorinated, and that would be the proper water that you need for this.
That would be ideal. The other thing you were mentioning at the beginning is, because like you said, replacing piping to feed showers in some locations could be a very expensive options. And everything we've seen today has been about plumb units, about showers connected directly to a water source. But there are options out there that don't require a plumbed water supply. How does this work? How does a unit work when you don't have a water connected to it?
So there are a product called a tank shower. And there's different versions of these tank showers that could use your existing low flow plumbing, or that could be self-contained. So if you go to a client, or if I go to a client and they don't have the budget to replumb, like I did one in Dayton, Ohio, it would have been $500,000 to replumb the unit, the whole location. Okay, which is not, that wasn't that big, 500,000. But we could do tank showers to replace and use their existing low flow plumbing that they had. And it came in at a fraction of the cost. So it's all based on cost and availability. Now, if they have no pipes at all, we even have self-contained units, or in the market, there's self-contained units that use water treatment modules that keep the water good inside these tanks for up to 1 year. But the modules work for up to 3 years. So there are options out there. If the client just doesn't have the fund, which happens, I mean, who has that? I'll tell you another one. I just did last week. A brand new plant. They planned for everything except for safety showers. I just got there, and I told them, you need to have plumbing. There's no way I could do self-contained units for this entire huge 4.5 million square foot plant. You have to replumb. It came out 5.25 million to replumb, to put in the plumbing. So so I'm saying, so we're working at different options for them to be able to. We're going to have to do these self-contained units to be able to mitigate that cost. Where at first, if they would have just done plumbing correctly, the thing would have been a fraction again of the cost using standard safety showers.
Yeah. Sometimes engineers forget about us. Emergency safety showers.
We're
So those tank showers,
one.
the way they get the pressure is through gravity. So it's a top fed, and it's gravity that provides the pressure, not the actual water feed on the unit. And that's for showers, but there's also many self-contained, we'll say, eye washes that go wall mounted also. So you don't need, if you only need an eye wash, you can also not have a water source and have like a wall mounted or portable eye wash used also. And you can get rid of many of these issues with the bad plumbing, right?
And the great thing about also having a self-contained or a tank shower is that it also has an emergent heater. So they keep your water tepid and brings you into standard in multiple areas.
Yeah, so there are multiple ways to get the water temperature, because a lot of, so something that it's come up recently, let's say in the last few years, is we talked about temperature. And there were places down south that usually didn't think much about it, because water coming out of the city water usually was within that range, 60 to 100, very typical down in Texas and in the Gulf on that. But in the last few years, they've had a couple of freezes. So they have to consider now to install options to warm the water, which they didn't in the past. So what we're seeing is some old sites that they have just regular showers installed outdoors that they used to work properly, no issues for many years. Now every year they're seeing a freeze, and they're having issues with the water temperature and the showers being protected. So it is very important to consider your environment, and if it's changing, what protection does the shower need? Not only everything we talked about, but what does the environment cause on your shower? Is the shower is going to be filled with water outdoors in Texas? It's going to be scalding hot when you turn it on. So you got to take care of, you got to be aware of that. And like I said, last year there was snow at the beaches in Texas. So you got to protect about freezing, where a few years ago you never thought about that. So you also have to keep your environment in consideration when thinking about probable issues you have with your safety showers, right?
So in areas where we were able to do safety showers, combination showers without heat trace and insulated, now we're recommending putting in freeze protected insulated units with a scald valve, so they can meet both of the areas. It can meet when it's really hot, but at the same time can meet when it's very cold.
When it's very cold. So that's definitely something to consider. The other thing that the ANSI standard mentions, and it's not a requirement, but it mentions, is the alarms, right? So depending on, when would you recommend a shower needs an alarm? In which situation?
Really remote areas. So there's a lot of areas that like example, tank farms. Usually tank farms are away from the main buildings, and those areas they're not frequently with people. So those areas you really should have an alarm. Maybe it's a central alarm where you connect a flow switch or a proximity switch into a a dry connect into the alarm system, or also have a horn and a light to be able to let people know there's an emergency. These places are usually very remote. Not a lot of people going there. So, if there's a hazard and it goes off, you really need to make people aware something's happening.
Yeah, no, definitely on that. So I think we covered a lot from the ANSI standard, from the basic requirements that the ANSI standard has on temperature, location, the way it operates, the dimensions on on the units, the flow that is required. And we went through some of the issues that we usually find. So when you're going through your showers, if this is too much, Just Right team can also work with you to do an evaluation and see where you're missing. We've been doing this for many years. Hughes as a brand has been over 50 years, and there's experience out there that can help you identify these issues. It's been a lot of information. Like I said, maybe getting somebody with experience, we can help you identify all the issues that you have on your site and see that if you're good, and if you're not, see what options you get to fix any of the issues you might get.
And most of the things that when I go around it's not off the shelf products that you need. So, there are many people that sell safety showers and Eyewashes combination, but it might not be the right one. Get an expert like us to come out there and help you find the right product. It might not be what you're thinking you need.
Yeah, what we've seen is a lot of people, obviously, and hopefully you've seen that today. There's a lot more information than what you might be aware, and getting a product to fit your requirements exactly, and not only about, like I said, plumbing, space, location, but also alarms, voltages, area classification, like all these things, what type of alarms are needed, what type of electrical requirements, all that can be discussed, and products can be are available that can meet your exact requirements. If you ask the right question to the right team, we can definitely offer that. Okay.
Absolutely.
So I think we've covered a lot today, and I think there might be we can go through a Q&A on that.
Yeah, great. As the gentleman just said, now is the time for the Q&A. So while we wait for that, I want to pass it back to you guys and ask you if there's anything that you want to reiterate, make sure that our audience keeps top of mind, to make sure that they're successful while we wait for their question.
Yeah. So the other thing that we can definitely include about the standard that we see on our customers, not only the location, like we said, is the electrical part. I usually, when I talk about safety showers, electrical is not top of mind, but there is a lot on the electrical requirements that different customers have, depending on your site that you need. If it needs, like I said, hazardous components, that's something to be considered. The voltages that are necessary. So a lot of, like Al said, off-the-shelf products are 120 volt, like they're very standard units, but there are options out there that you can go depending on your specific requirements at your site that you may need to get that. And the main use of the electrical requirements is on the heating the water. So when you're on cold weather, if you're more north here in North America, warming the water will be one of your biggest challenges on an investment where you're talking about emergency safety showers, because there are multiple ways to warm water, but you'll need something that can meet the flow requirements of 20 gallons per minute ready within 1 second. And that can be achieved in multiple ways. And there are electrical ways to do that, to inline heaters, but sometimes that requires a lot of power. So also taking in consideration when you're installing new applications, how are you going to get the right temperature? And that will be through the proper electrical components for tankless heaters, hot water tanks, mixing valve, just to make sure you got the right temperature. Sometimes that's overlooked, and you can't, like when you're home and you're turning the water at the faucet at your home, you can wait for the water to be warm and you can wait a few seconds. On an emergency, you don't have that luxury. So you got to make sure the way you're warming the water, it's fast enough and has the correct flow for an emergency safety showers, right? Have you seen something about the temperature out that you might want to share, that issues that you have with customers?
On the temperature is, it's either too high or too low, but what I've been really promoting lately is tankless water heaters. But it can't be a tankless water heater that you buy at a Home Depot. It has to be a commercial grade that has that 1 second turnaround. So I've been able to meet the standards, meet those tepid water standards really easily with a electric a tankless water heater. It cannot be gas powered. It does not meet the standard. because you have the 1 second. So there are some really good commercial units out there. And if you have any questions, we'll be more than glad to talk to you about that offline.
Yeah.
Now,
so you can
go ahead.
You can keep hot water and mix it with the cold, or you can keep the water at a tepid temperature when you're using, like you mentioned, a tank shower where all the water is held at the right temperature. So you don't, it's already ready to go. You don't need to mix it or anything. Or like you said, inline heaters on that one. It depends on your application. If you're gonna do a new install, multiple options apply. But if you're going through an old site, then it depends on what spaces are available, how much voltage is available at your site, how much power is available, to see what the best option is for your specific location to get the water at the right temperature.
If they have the right size pipe, or if they don't have the right size, we could do a remote tank. There's remote tanks you could do on the floor. There's the tanks that go over the head. And all these are designed to keep your water tepid, so that when you too turn it on, in that 1 second, you get tepid water right about 84, 85 degrees.
So water temperature, definitely a challenge, and something you want to take a look, depending on your site, what's the best option on that one. Like we said on the flow, the piping is something that is not on the safety shower side, but it might be too expensive. So you might want to see alternative when you're talking about improper piping needed for an emergency safety shower, like we discussed. Yeah.
So there are some questions here, just so you can know, George. I don't know if you see them.
Okay.
The first one is, how well can these ANSI standards be met if you are using a faucet-mounted eyewash? For instance, if we have one mounted on a faucet that can be turned on with 2 hands to the faucet, then then another touch of the diverter, temperature adjusted by the user while using it. It does not meet the standard. I can tell you right now that is completely it's not does not meet the standard. You have to have it hands-free, just one push of the paddle, and the water has to come out tepid immediately. So unfortunately, that one is a no-go. It would be a full fail on an audit. And if it does get audited by an ANSI or OSHA person, that would be it would not be allowed. Am I correct, George? Any questions on anything on that one?
Yeah, so that's definitely it. So it needs to be one movement to be open and then remain open. So if you need to take the multiple steps to get it open, that's definitely a problem. I see the next one. It says, how is it possible that at some sites safety showers are installed in close proximity to electrical panels and told it is okay? So the only thing to consider here, if that electrical panel is NEMA 4, it is completely watertight, then it might be okay. But it's usually not the case. And if you're asking this question, imagine that's because that's not the case. And I've seen this multiple times when visiting customers, where there's a safety shower and there's just a power outlet close by. I don't think I have to explain what can happen if you're taking a shower next to a power outlet or something like that. So you got to make sure that everything on the spray pattern area and on the floor, because again, there's a lot of water going to be on the floor, that nothing can expose electricity or damage any electrical equipment. That if there is an electrical equipment, they need to be sealed and completely watertight, so the shower won't hit it on that one.
You need to have proper drainage because, like George was saying, there's 300 to 500 gallons of water going to hit the ground. And if you don't have proper drainage, that water will rise and will cause issues with the electrical. So I do not ever put in any safety showers near an electrical panel. I just don't like it. Don't trust it, wouldn't do it.
Correct. You want to take the next one?
I have no idea what this is, to be honest with you. What are the standard
preventive maintenance frequencies? What steps need to be followed for each frequency? So
I wasn't sure what that meant, so please, George.
So the preventive maintenance, so I'll mention that the showers need to be tested weekly, activated weekly, flushed weekly, mostly for the stagnant water. If you're using self-contained units that are not plumbed, you only need to do this once per year on the flushing on the unit, and just need a visual inspection on the unit. So if it's plumbed, you need to flush it, activate it weekly to make sure you flush any stagnant water on that one. If it's self-contained, you got to follow the manufacturer recommendations. Self-contained eye washes that use an additive usually needs to be flushed and the water and the additive replaced every 3 to 4 months. If it's a tank shower with a cartridge, like some of the options that we offer, it's a year. So you got to follow your manufacturer recommendation for self-contained units, but at least once a year minimum, you got to flush it and test it completely. So those would be the frequencies.
How about for flow rates? What do you do for flow rates? How often?
Well, the flow rate that the ANSI standard requires that you check it once a year minimum. Check that it's meeting the ANSI standard.
Right. Perfect.
Okay.
So one of the things is testing it weekly. They're not usually testing for flow and patterns. So I actually recommend doing that at least once a month, but the minimum is once a year.
Gotcha. Yeah. So definitely you got to look out for other issues. What are the requirements for drainage systems? You were talking about this, Al. Sometimes the stations are an afterthought and maintenance is being done using buckets because there is no drain system. Yeah, that's
this is the bane of my existence here, the drainage. Oh my God. There really isn't anything in the standard that says about drainage, unfortunately. The drainage is something that it's always an afterthought. So like for us, we've created some systems that have sumps and pumps to be able to push that water out to where the drain is. But also sometimes is the distance of where that drain is. Sometimes you have some massive pumps that are needed to push the water to the drain. But we created certain units that have the sump and pumps where some drains are overhead, like let's say like with server rooms, the wires go on the bottom while the water and the drains go over the top. So we have a sump and a pump that can push the water up and away. So to avoid that. But unfortunately, buckets, that's what the problem is. There's so much water that hits the ground, it causes such a hassle. So there's not an easy answer for that, unfortunately.
And the other thing about drainage is, like Al mentioned, that sometimes we recommend scald valves and freeze valves. What these valves do is when the water is getting too cold before freezing, it opens and drains water. So fresh water comes in. The same with the heat. If it's going too hot, it opens. That causes water to go into the floor and it creates maintenance issues. So drainage also is not only when you're using the shower, when you're testing it weekly, and if you have any safety like a scald valve or a freeze valve, all that creates water that needs to be considered when you're talking about drainage on the site.
And I see this a lot in labs. How about labs? Labs is really where I see the biggest issue when it comes to drainage.
Yeah, labs is usually a problem. There's expensive equipment and usually not enough drainage in the floor. So you need a contained unit like a cubicle that you can keep all the water inside the cubicle and drain it safely somewhere else if that has been considered. For sure. Ooh. Then it says, when is it acceptable to use supplemental eyewash bottle versus plumbed eyewash station? And what are the pros and cons supplemental eyewash bottle? That's a great question because there's a lot of confusion. So the eyewash bottles and plumbed eyewashes serve two different purposes. So let's talk about first the ANSI standard. The ANSI standard talks about supplemental units, and they are not to replace the eyewash or the shower. And they mention things like handheld drainage hoses and other type of equipment that can supplement a unit, right? But the eyewash bottles, they're not a replacement for plumb eyewashes, and they're used to remove debris from the eye, not chemicals. So if you're working in an environment where you may get debris in your eyes, like dust or something, the bottles can take that off your eyes. When it's chemical, you need the eyewash, right, Al?
Correct. So again, whenever I go and I see the bottles, I tell them to move them, throw them away. It's a first aid. It's a first aid product. It's not to meet the standard. ANSI is specifically 15 minutes. So those bottles, you only get seconds, a minute maybe of eyewash, so it does not even come close to meeting the standard. So get rid of them. You could use the ones that hang on the wall. The self-contained 15-minute eyewashes are perfectly okay, but the bottles are not okay. Those are good, like if you're in a warehouse with cardboard and there's dust, and you could put those bottles to just wash off your eyes if you get some dust in your eyes, but not as an ANSI or OSHA standard. It actually, I've actually seen OSHA give huge fines for having those bottles.
Right. So again, they're different products for different purposes. If you think you have an eyewash and what you have is a bottle, you don't have an eyewash. You have just something to clean your eyes if you have some debris. But if there's a chemical issue, you need a plumbed eyewash. or a self-contained eyewash that
Oh,
provide a
self-contained.
15-minute, like Al mentioned before. Okay. So I think we covered all of the questions there about the supplemental units that they were talking. The ANSI standard also talks about supplemental units for location. There's some locations where there might be a risk and there's no way to put a shower there for X or Y reason. So you can, the ANSI standard allows for some units to be do some like first aid, so they can take a first wash and then move to a proper shower that is a little bit more than the 10 seconds. They talk about the supplemental units that can be used temporary or in location where it's just impossible to have something, but that's just to get you to the proper shower on the unit. Or the drench hoses. A drench hose on a unit, which could be a shower and eye wash, it's not a replacement for a shower and an eye wash, because again, it needs your hands to operate. So it won't replace anything. You need your both hands available to take a shower or an eye wash or an eye face wash. So drench hoses are good, but they do not replace a unit when you're thinking about an eye wash.
So the supplemental units are Band-Aid, while there's absolutely no other option. And also training has to be included in that. So if you are going to be using a supplemental system, if there's no other option, then the people have to be trained that if this happens, you put them under that shower eye wash for whatever, a minute, 2 minutes, whatever it is, and you have to have a plan in place immediately to where that person is going to be going to if something really does happen. So if you do get audited, you need to have what you're using plus that training program together for it to be able to pass.
Okay, so if there are no more questions, again, Hughes safety showers, part of Just Right, and our distributors. We can cover there's a program we do called Study, which goes through your company and takes a look at all this, and plus other things you might have at your site, and just provides a report that says where you're failing on the different health and safety requirements, not only safety showers, but other parts of the Just Right group. So that's another option you have to make sure you're up to spec and everything is meeting the correct standards for your site. So if you're a health and safety professional and you're worried that you're not meeting everything for the safety of your personnel, give us a call to Just Right, and we can definitely schedule a meeting to go through and make sure you have everything being covered at your site and get you a report that can be used at.
We'd love to help, and get us in early. Try to get us in early if you do need us. Get us in early on your project, in which will save you lots of money.
Definitely.
Perfect. Well,
and I'd just like to add really
Megan.
quick, Samantha. Sorry, that service that we provide, the site safety audit, is free to our customers. So please, if you've got any questions, take advantage of this opportunity. You will not be charged an audit fee for this. We're more interested in making sure that you're protected and have the right products in place.
Fantastic. Well, I want to give all of you a huge shout out for your valuable information today. We covered a lot of things, so make sure that you're reaching out to your Just Right team to make sure you are compliant, to make sure, as Megan said, you're getting the right knowledge and you're doing the right things, and you're making sure that you're safe on the job site. So I want to give you guys a huge shout out and a big thank you for being here and putting on this presentation. And of course, I want to thank everybody in the audience, because without them, none of this would be possible. So thanks again. Take care and stay safe. Bye, everyone.
Thank you.